वेलकम बैक। सो क्या चल रहा था? स्ट्रेस कंसंट्रेशन। स्ट्रेस कंसंट्रेशन, राइट डाउन। व्हाट इज स्ट्रेस कंसंट्रेशन? So in any member, when load is applied, so it will be called loaded member. So in loaded member, if cross sectional area is throughout the length constant, means it is a prismatic bar, then there will be no stress concentration. But if the cross sectional area is suddenly decreasing at some section, their stress concentration effect will be there, okay, due to sudden decrease in the cross sectional area, because load will remain same, area is decreasing, so value of stress will be increased suddenly only for that section. So chances of failure at that section will be more, okay, due to stress concentration. So this whole phenomena is called stress concentration. Write down here. It is defined as the localization of stress, defined as the localization of stress due to sudden change in cross sectional area, sudden change in cross section area at any section, in the loaded member, okay. Next point, the maximum stress at minimum cross section, the maximum stress at minimum cross section is called nominal stress, is called nominal stress, is called nominal stress, okay. So you can draw it like this. Let's say there is a member, there is a member like this. This member is having uniform cross sectional area throughout its length, and it is loaded like this, okay. So here everywhere at all sections the stress value will be same, whether you take this section or you take this section or you take this section. So at all sections the stress value will remain same, let's say for this section the stress will be like this, so everywhere it will be plus P by A. Let's say A is the cross sectional area, okay. Now if this member is, let's say, bored or drilled, if this member is bored or drilled and a hole or cavity is made inside this, like this here. Cavity or hole is made inside this here. Okay. Then here cross sectional area is same up to this section. So stress will be uniform. Here cross sectional area is same up to this section. So stress will be same. But after this the cross sectional area is suddenly decreasing. So in this zone stress concentration will happen. Okay, stress concentration will happen due to sudden change of the cross section. Stress concentration will happen. So how this stress concentration must be represented? So stress concentration is represented with the help of stress lines. Stress lines is no any physical significance. They don't exist physically, but this is only an imaginary concept. Okay, so here stress lines will be like this. Stress lines will be like this. So it is represented by the stress line, just like flow of water or flow of liquid. So flow will be here everywhere uniform, but when liquid will be flowing here like this, here stress lines will be far away, but here when all the liquid particle will enter into the small cross section area like this, so here stress line concentration will be more. So when stress lines will get closer to each other, it will be called stress concentration. Okay. So you can draw stress lines here also. Stress lines. Stress lines will be like this. Stress lines will be like this. Okay. So these are the stress lines. So here you can see stress concentration is happening. Stress concentration is happening. Stress concentration is happening. Now here area will be the minimum area. Okay. So stress value will be maximum. So maximum stress value at minimum cross section is called your nominal stress. Is called your nominal stress. So this maximum stress value will be sigma O, or you call it nominal stress. Nominal stress. So nominal stress in this zone will be more than stress at any point in this zone. Got the point or not? So simply it is more than the simple stress. All done. Now you can imagine, just like we do the आइजोड चारपी टेस्ट किया है ना, आइजोड चारपी टेस्ट, उसमें आपका जो स्पेसिमेन रहता है, दैट स्पेसिमेन इज मेड लाइक दिस. एक वी groove is present on the specimen. Yes or no? A V groove is present on the specimen, and this side of a specimen is fixed. This side of specimen is fixed, and hammer will come and hit the upper part like this. Hammer will come and hit the upper part like this. Okay. So when it will hit the upper part like this, at this section, bending stress will develop in this. So the stress concentration will happen like this. Stress lines will be very closer to this point like this. Here there is minimum cross sectional area, so stress lines will get concentrated at this point, and in this zone there will be stress concentration. In this zone there will be stress concentration, and this will be your minimum area of cross section. Minimum area of cross section. Okay. So why that V groove is made here? Why that V groove is made here? So that stress concentration can take place and failure can happen only from this section. Okay, and failure can happen only from this section. Yes or no? So this test generally we do. And if there are few members, or shaft, let's say, and it is rotating, let's say this is shaft and it is rotating between these two bearings, okay, and there is a rotor on this, let's say, these are the bearings in which this shaft is rotating. Now one rotor is there placed on it. Let's say this is the rotor. Rotor is like this. So there will be weight of rotor also. So when it is rotating, weight of rotor will be acting here like this. So there will be always stresses acting on this shaft or member. Now if in this some micro level defects are there, let's say defects are like this. So there is any surface crack like this, very small surface crack. So if surface crack is present, crack can be internal crack also. This is internal crack. Internal cracks are not so much dangerous as the surface crack. There is surface crack like this. Okay. And if we see by the microscope, there are many surface crack already present on all the shafts. We cannot completely remove it. So whenever this shaft is rotating continuously, so this part will go in tension and compression subsequently. Sometime there will be tension and sometime there will be compression. So whenever it will feel the tension, it will go on that side. When it will be in tension, then crack will propagate, and stress concentration will happen here. Stress concentration will happen here. Yes or no? And due to this stress concentration, large value of stress will act there and chances of failure will be very high from this section. Yes or no? Chances of failure will be very high from this section. Okay. So this is how whenever there will be sudden change in cross-sectional area, there will be nominal or maximum stress acting on that cross-section. That stress will be the maximum stress and it will be called nominal stress. Got the point or not? And this effect is called stress concentration. So chances of failure due to stress concentration will be more. Note down up to this. फिगर बना दिया. फिगर बना दिया. All done up to this? Okay, good. Now, next head